guys, this is Mrs. Verona. I'm going to be doing another mini lesson on matter. When you think about matter, it's just any substance that has mass and takes up space. Well, we can actually break it down into two things, pure substances and mixtures. Pure substances are really easy because it's a constant composition. It's going to be made up of elements and compounds. So I could look at this and say carbon, oxygen, gold. All these are elements on the periodic table, and they're going to be falling under this pure substance composition here. If I look at compounds, it could be water, sodium chloride, copper 2 chloride. Any of these things are going to be falling under that compounds. So it's just a combination of elements coming together to form a compound. Now, when I look on the opposite end, the mixtures, these guys are going to be different because this one's a constant composition of only water molecules or only sodium chloride ions here. Now, when I come and look over here at the mixtures, you're going to notice that there's two types of mixtures. It could be a homogeneous mixture, also known as a solution. You'll have visibly indistinguishable parts. That means it's going to be even throughout. You wouldn't be able to tell the difference if there's stuff in there. Examples of this is going to be like air, brass, Kool-Aid. Now, when I talk about Kool-Aid here, it's going to be like the Kool-Aid when you actually follow the directions and you mix the proper water and the Kool-Aid packet and the sugar, and you don't have that big layer of sugar sitting at the bottom. Okay, so if you follow the directions correctly, Kool-Aid should be a homogeneous mixture. Heterogeneous mixture, on the other hand, is going to be visibly distinguishable. When you start thinking about this, if I would go get beach, sand, and water, all in a bucket. I would have liquid, which I would have the salt water. I would have sand. I could probably have seashells. I might even be lucky and get a little crab in there. Who knows? Other heterogeneous mixtures. I don't know if you guys ever had this, but Jell-O with fruit in it. It was one of those things my grandmother loved to make for us. Definitely one of my favorites. Also, granite countertops. If you even look at our floor here, when we start seeing the different lines of it. Nope, that's not a good example. All right, so even granite is going to be another wonderful example of a heterogeneous mixture. Now, when we start looking at these mixtures, there's different ways to separate them, and a lot of them are through physical means. And if I separate things through a physical mean, that means I am retaining the item. I'm just putting them into like little piles. One of the easiest ones right here to think about is going to be this beach sand water in a bucket. I could very easily go and get a filtration system and throw that beach water and sand through this like funnel. All the salt water is going to go down into the bucket, but now up on top, I'm going to have my sand, my seashells, and hopefully my crab. You never know. And then I can go and physically use fingers to go and pick out stuff. I could also use one of those little sifters and just kind of sift through, and all the fine grained sands are going to come down, which will leave me my seashells and hopefully my crab. So different ways to go through it. If I wanted to go and separate that salt water, that seawater, I can go ahead and use a distillation apparatus, and it's got a round bottom flask that sits kind of on a sand base, and you heat up that sand, and it causes that water to heat up. And you're going to notice that we can evaporate the water, so it change from its liquid phase into a gaseous phase. It's going to rise up to the top, and then I've got this collection chamber that will go and collect the pure water, leaving the salt behind. And so that's another method to separate things by physical means, because all I'm doing is changing phases. And I'm still keeping the identity of my substance. I still have the salt, I still have the water, it's just been separated. You also have another type of separation system is a chromatography system. And when you look at that, you may have done that in biology. If you all got in the leaf and just kind of used a quarter to kind of rub at the bottom and set it into an ethanol solution, you would notice that the ethanol would start rising. It would start separating the pigments of the leaves, and you could see the carotene and the chlorophyll and all sorts of things. So all these are different ways to separate our mixtures through physical means, because I'm still retaining the property there. If I completely change it, for example, if I would take pure water and I would apply electricity to it and break down my water into hydrogen gas and oxygen gas, Well, now I have brand new substances and they're no longer going to have the same property of water. So big difference between physical and chemical change. Thank you guys.